Prime factorization. What on earth is this? Guys, please, if you don't know what something is in maths, Google it. Actually, that goes for anything, not just maths. Just Google it. If you type in prime factorization or what is prime factorization on Google, I'm telling you now, you will get the proper definition for it. You don't have to come here, let's be honest. Okay, so, what is this? It is representing a number as a product of its prime factors. Okay, there's more technical terms happening here. Remember, products. What does product mean? In mathematics, product means multiplier. Okay, so in other words, you can represent a number through a series of other numbers that are multiplied together by one another. Okay, that's still confusing. What is a prime factor? What does this word mean? This word is simply a number that is a factor as well as a prime number. Let's take, for example, the number 10. The number 10, the factor pairings of 10 is 1 and 10, obviously, 2 and 5. Out of all the factors of 10, these are prime numbers. Remember, 2 is a prime number, 5 is a prime number. So, in other words, 10 can be written as 2 times 5, a product of its prime factors. Now 10 is a low number, so what about the bigger numbers? So the way that I do this, if I wanted to factorize 216, I set up the skeleton diagram, this like ladder type scenario, and my aim is to reduce it to 1 by dividing it constantly. Start with the lowest prime factor of 216. It's an even number. The lowest prime factor obviously has to be 2. Okay, chances are you always start with 2 or 3 or 5. It's generally one of those. Okay, so in other words, if I halve 216, get your timetable game on, get your mental maths games on. Okay, so if I reduce that, that will be 108. Now I need to look at the next prime factor. Can I still carry on using 2? Yes, I can. It produces an even number, so I can still use 2. Okay, I can still use 2. 54 is another even number. I can still use 2. That can drop to 27. Okay, 27. Now, obviously, I can't divide 27 by 2 evenly. Remember, we want to divide it evenly. So I look to the next highest prime factor. That would be 3, not 9. 9 is not a prime number. It would be 3. 27 divided by 3 would be 9. I can carry on using 3. That would give me a 3, 3, and I need one more line to give me a 1. This is my goal. That's my goal. My goal is to give me that 1. If I can reduce 216 down to 1, I know that I've done it correctly. Okay, so in other words, 216 can be equal to 2 times 2 times 2 times 3 times 3 times 3. So in other words, 2 to the power of 3 times 3 to the power of 3. There's 3 2's. That's what this guy means. And there's 3 3's. That's what this guy means. Okay, let's look at another example. 252. Obviously, I need to start with my lowest prime factor. Again, this is an even number. So it's going to be 2. If it's an even number, just throw that 2 in there. 126 is also an even number. Okay, it's also an even number. So therefore, I would use another 2. 126 divided by 2 is equal to 63. Okay, obviously 63 cannot be divided by 2 evenly. So now I'm going to turn to 3. 3 is the next highest prime factor. Remember, these can only be prime numbers. 63 by 3 will give me 21. I can use 3 again. I'm going to have to throw in another rung. 21 divided by 3 will give me a 7. 7 is the next highest prime factor. See what I did there? Just straight. Okay? If I can get this phenomenon, that's to 1. I know that I'm correct. Okay, so in other words, I'll write it up. Yeah, 252 will be equal to 2 times 2 times 3 times 3 times 7. So in other words, if I write it in exponential form, it'll be 2 to the power of 2. There's 2 2's. So it's 2 to the power of 2 times 3 to the power of 2. There's 2 3's times 7. I've expressed these numbers as a product of their prime factors, representing a number as a product of its prime factors. So in other words, instead of saying 252, I can say 2 squared times 3 squared times 7. Same with the 216. I can rather say 2 cubed times 3 cubed. Okay, that literally is prime factorization. Common mistakes, because those are always prevalent in mathematics. I'm going to just draw an untidy skeleton diagram. Try use a ruler. If we take the number 138, okay, like I said before, it's an even number. we start with 2. Okay, that's easy, right? That will simply be 69. Alright, so obviously I can't carry on going with 2, so the next one would be 3. Okay, 69 divided by 3 will give me 23. Now I'm looking. 23 cannot be divided by 3 evenly, 4 evenly, 5 evenly, 6 evenly. The reason being this doesn't work. 23 is the next prime number. Yes, it looks weird, but it's true, I promise you. 23 is a prime number, therefore 138 will equal 2 times 3 times 23. That is perfectly valid. That is 100% correct. Okay, don't be fooled. Prime numbers don't have to be small, they can get very big. I would suggest learn your prime numbers maybe between 1 and 50, maybe 1 to 100. The more prime numbers you know, the more experienced you'll be in this department. But you know, the crux of this video is, you know what, just Google it. You don't understand something, just Google it.